Welcome back everybody. I am a teacher from Ilm Online Academy. In today's video, the topic is Introduction to Organic Chemistry. This is basically chapter number 18 of the ongoing series for the Cambridge Chemistry 0620, and in today's video, we'll be having a look at the organic chemistry. So first of all, I will share with you the contents which we will discuss in today's video. The first content which we talk about is the name and the formula of the organic compounds, and the second thing which we discuss are the structure formulas and homologous series of the organic compounds, and also with the isomerism phenomena. So these are the contents which are included in today's topic. So let's first talk about organic chemistry. We will first start with the organic chemistry. As you can see here, organic chemistry is the carbon containing compounds that are present in our chemistry. The chemistry of the carbon containing compounds is known as organic chemistry. So we can say that the compounds in which we talk about the carbon, as carbon is unique in the variety of the molecules it can form, so the chemistry of the carbon containing compounds is known as organic chemistry. We have two different branches. You can say that the organic chemistry and the inorganic chemistry. In organic chemistry we talk about the carbon containing compounds, and in inorganic chemistry we talk about the other elements that are present in our periodic table. So there are special features of those carbon containing compounds, like as you already know that carbon is a non-metal, so basically it forms the covalent bond. So the special features of the covalent bondings that involves the carbon are: first, carbon atoms can join together with each other to form the long chains, or like this one. This is the first one. Carbon atoms join together like this. They can form a chain. So millions of carbon atoms join together to form a compound. There are long chains. Atoms of other elements can also attach to each chain, as we already know that the valency of the carbon is 4. So total 4 bonds are formed by each carbon atom, and also other elements can be joined together with these, and so on up to n number of molecules can attach with this, so that it can form the long chain. So this is the first one, that atoms can join together to form the long chains. Second, the carbon atoms in a chain can be linked by a single, double, or a triple bond. As you already know about the single, double, and the triple bonds in the covalent bonds, we have already read about the covalent bonding in our previous chapters. So carbon can form a single bond like this, and then you can complete or satisfy the 4 valences. Carbon can also form the double bonds like this one, and then 2 other bonds are formed by the other elements. And if we talk about the triple bond like this one between the 2 carbon atoms, and then one element will satisfy its valency. So carbon atoms in a chain can be linked by a single, double, or a triple covalent bonds. Carbon atoms can also arrange themselves in the rings also. In that one we have, so in case of the ring structure, what will happen? We have carbon atoms like this. They can join together with also other atoms, and also some other carbon atoms can also join like this. So just like that, you can see here they can form a ring structure. A ring compound is also formed by the carbon atoms. They join to form the ring molecules. Like for example, we have a glucose molecule, we have long chain fat molecules that can also form together, and they form the large or long atoms, and long chains are formed by them, and also ring structures can be formed by these one. Carbon is very versatile and able to form the chain and the ring structures. So in organic chemistry, we basically focus on the studies on the structure, properties, and the reactions of the organic compounds that contain the carbon in their covalent bonding. So basically in the organic chemistry we talk about the hydrocarbons, mostly talk about the hydrocarbons, the compound which contain the carbon and hydrogen in their structure. Hydrocarbons are one of the simplest type of the organic compounds, and hydrocarbons are the compounds that contain only carbon and hydrogen atoms are present in them. So in organic chemistry we deal with the hydrocarbons, and organic chemistry contains organic compounds contain the carbon and hydrogen only, and in inorganic chemistry we talk about the other elements that are present in our periodic table. So in the hydrocarbons are the compounds that contain the carbon and hydrogen only, and the simplest type of these hydrocarbons, we have the classification of the hydrocarbons. We have some series of the hydrocarbon that are present there. First we have alkanes, we have alkenes, and also alkynes. So these are considered as the hydrocarbons. You can say that alkane, alkenes and alkynes are considered hydrocarbons. We have hydrocarbons studied at this level, and they can be subdivided into the different families and or the series, like we have alkane series, alkenes, and the third one is the alkynes. So these are the series of the hydrocarbons, and each have a different general formula. For each of the formula we have, first if we talk about the alkanes, then alkanes have the general formula of CnH2n plus 2. This is the general formula for the alkanes family. For each formula below, which I am writing here, n is the number of the carbon atoms that are present in any molecule. Like for example, if you find out the first member of the alkane family, then you have to put 1 in case of the n. Like for example, C1H2 1 plus we have 2. So if you simplify this, we have CH4. So this is the first member of the alkane family. If you want to calculate the or check the second member of the alkane family, then you have to put the 2 instead of the n. So this is how you can easily find out the members of the alkenes family and alkynes family by their general formula. So if we talk about the next general formula for the alkenes, we have CnH2n. These are the general formulas. After that we will talk about or discuss in detail about the alkanes, alkenes and alkynes. And third, if we talk about the alkynes, we have Cn H2n minus 2. So this is the general formula for the alkynes. So next we will talk about or discuss in detail about the alkanes. Some hydrocarbons are saturated, means that these molecules contain only single covalent bonds that are present in them. So that's why we call them as saturated hydrocarbons. Saturated are those in which just only single covalent bond is present between them. If there is any double or triple bond, then that is known as the unsaturated hydrocarbons. So the family of saturated hydrocarbons is known as alkanes, and these molecules contain only single covalent bond between the carbon atom. Since carbon has a valency of 4, so the bonds not used in making the chain are linked to the hydrogen atoms, because we are talking about here the hydrocarbons, basically the chemistry of the carbon and the hydrogen atoms. So no further atoms can be added to the molecule of these compounds. That's why we call it as they are saturated hydrocarbons. So alkanes is a series of hydrocarbons with the general formula CnH2n plus 2. They are saturated compounds and they have only one single bond between the carbon atoms. No other double bond or triple bond is present between the carbon-carbon atoms. Only a single bond is present between the carbon atoms in their structures. Like for example, if we talk about the simplest alkane that contains one carbon atom, that is known as methane. The simplest alkane is the methane, which has a formula CH4, and the structure of this methane is CH4. 4 hydrogen atoms are there, and just one carbon atom is present in this. So we have a this is the methane molecule and covalent bonding is present in them. The series of the alkane compounds is built up by simply adding an extra carbon to the chain. Like if we talk about the second one, the second member of the alkane family, you just have to add one more carbon atom like C2, and with the general formula you have to put the 2 here plus 2. So this is general formula, and the formula for this one will be C2H6, and the structure for this one is carbon carbon single bond, and then you have to place 3 hydrogen atoms like this. So this is the second member of the alkane family, and this is ethane. The first is known as the methane and the second one is the ethane. So the name of this series of these hydrocarbon ends as ane because of alkane. The name of these members ending with the ane: methane, ethane, propane, butane, pentane, hexane, heptane, all these are the members of this family. So the first part of the name is the prefix that tells you the number of the carbon atoms in the chain, and the second one represents the alkane. So we have methane, ethane, propane, butane, pentane. So all these are the members of the alkane family. So this one is the table with the names and the molecular formulas of the alkane. As you can see here, we have a prefix. The prefix represents a number of carbon atoms in the first member of the alkane family that has a name of methane. So the prefix is meth, and you have to add the name of the family, that is alkane, that ends with ane. If we talk about the alkenes, that ends with the ene, and if we talk about the alkynes, they will end with the ine, like this. The prefix which we use is the same in all, like methane, ethane, and in case of alkenes, the first member is ethene. So next we have propane, and next we have butane, which we will talk later. So the prefix is meth, eth, prop, but, and pent, and the molecular formula is here. You can easily do the molecular formula just by this journal formula, as I already told you. So the formula that are given in this table, these are the molecular formula of the compounds, and they show the total number of each type of atom in a molecule of the compounds. Like each molecule increases just by CH2. If you add CH2 in the previous one, then you get the other one. Like for example, we have the formula of methane, CH4, and you have to find out the molecular formula for the next member. You can easily find out by this general formula, and the second method for this one, you just have to add CH2 in the previous one, and then you get the formula of the next member. Like we have C2 and H6. So you can see here, this is the formula for the ethane. So you can easily do this, just there is a difference in the CH2, one carbon and 2 hydrogen atoms. So the formula for these molecules also for the journal formula, where n is the number of carbon atoms. This n, which is in this structure, that is the number of carbon atoms. So you should know that this is the number of the carbon atoms that are present there. So if you know the number of carbon atoms in an alkane molecule, then you can always work out the molecular formula. So in organic chemistry, the structure of a molecule is very important. We have a displayed formula that shows the bonds between all the atoms in the molecule. Like this one is the displayed formula for the alkanes, like methane and ethane, that show the bond between the atoms in a molecule, and the displayed formula of the alkanes emphasize the fact that these molecules are saturated, means that they contain only single bonds in their structure. So all bonds between the carbon atoms are the single bonds that shows us by the structure of these compounds. So this is all about the alkanes. We have read about the journal formula, about the members of this family, and in the last we talk about the naming of these compounds. How can you name them? Just by adding the prefix, and the ending will be with the ane. So next we will talk about alkenes. So alkenes, the ability of the carbon atom to form that double bond with each other give rise to alkenes like this carbon-carbon double bond. So if there is a double bond that is present between in any structure, you call it as alkene. If there is a single bond, you call it as alkane, and double bond represents the alkenes. Alkenes are another family of the hydrocarbons. Alkenes have a general formula which I told you that, which is you have Cn and H2n. So this formula, by putting the number of carbon atoms in place of the n, you can easily find out the formula and also the name of that compounds. So there are note that there are 2 less hydrogen atoms compared with a similar alkane because of the presence of carbon-carbon double bond. The first member, or you can say that the simplest alkane must contain 2 carbon atoms. That is the condition which are needed for the carbon-carbon double bond. Because double bond is required between the 2 carbon atoms, so the first member or the simplest member of alkene is ethene. It does not start with the meth, it will start with the eth because of the condition that it requires double bond between the 2 carbon atoms. There should be a one double bond between the 2 carbon atoms that represents the alkenes. That is the condition. So we call it as the alkene. So I will also show you here the diagram of the bonding in the ethene and the structure also of this one. So ethene, if we talk about the formula, so the this member of alkene starts with the ethene. It contains 2 carbon atoms, so you have to place the 2 in place of the n like this, and then 2. So we have the formula which is C2H4. So this is the molecular formula for the ethene. And if we talk about the structural formula, then that will be carbon-carbon double bonds, and we have, you can say that we have total 4 hydrogen atoms that are placed here. The one thing that is important, that carbon has the valency of 4. The valency of carbon is 4, so you have to make sure that carbon make a total 4 bonds with the other atoms. Like carbon makes the first bond with this hydrogen, second with this, third in here, and with this 2 bonds with the same carbon atoms and 2 bonds with the 2 hydrogen atoms. So you can see here we have satisfied the valency of the carbon atom. So this is the first one member of the alkene family. And next, if we talk about the next member, that is propene. Propene is the next member. So it contains 3 carbon atoms, C3 and H2, and you have to multiply it with the 3. So the molecular formula will be C3H6. So there should be a single, like you can say that there should be one double bond present between the 2 carbon atoms. So first you have to make sure double carbon-carbon double bonds and then carbon single bonds. Then you have to add the hydrogen atoms. Like this carbon already made the 2 bonds with the second carbon atom, so you have to place the 2 hydrogen atom here, and then just 1 hydrogen atom here, and 3 hydrogen atoms will be placed with this carbon to satisfy its valency. So this is the structure of the, or you can say that the bonding in the second member of the alkene, which is propene. Now I will show you here the names of the first members of the alkene. So this is the table for the names and the molecular formula of the first 10 members of the alkene family. This table shows the name and the molecular formula. Note that they have same prefixes that we use for the alkanes that are also used to indicate the number of carbon atoms in the molecules. So we have the first member of the alkene family start with the 2 carbon atoms. Why? As we already told you about that why it starts with this, just because there is a condition there should be one double bond between the 2 carbon atoms. So with 1 carbon atom it's not possible, so we put the 2 carbon atoms in it. Note that the same prefixes are also used here to indicate the number of carbon atoms that are present there and the number of presence of carbon-carbon double bond in the alkene molecule makes alkenes much more reactive than the alkanes, because if we talk about the single bond is less reactive, or you can say that it's a stronger bond. So a lot of energy is required to break this one. But if we talk about the double bond, this is unsaturated. The single bond is called as the saturated one, and the double bond or the triple bond is known as, or you can say that this is the sign for the unsaturation. This is a weak bond, so you can easily break them, and that's why they are much more reactive, just because of the presence of this pi bond. Alkanes contain only single carbon-carbon single bond. Other atoms can add to the alkene molecules when the double bond breaks open. So that's why the alkenes are known as the unsaturated hydrocarbons, and this difference is the basis for a simplest test for the unsaturation in any hydrocarbon molecules. So this is the second family for the hydrocarbons, and the third one we talk about, which is alkynes. Alkynes with this is the third family of the hydrocarbons, and the alkynes are also unsaturated hydrocarbon. As the molecule contains the carbon-carbon triple bond, there should be one triple bond present between the two carbon atoms, as the molecule contains here. So the simplest member of this one is ethyne. The prefix will be the same, but just there is a difference in the ending, an ane, ene, and ein. So the formula for this member is C2H2, and the general formula CnH2n minus 2. Through this general formula, you can easily get the formula of any member of this compound. So this is all about the alkynes, and just like the alkenes, we have also the members of the alkynes like ethyne, propyne, butane, pentynes. So further with this, we will not discuss more about the alkynes at this level, and next we will talk about the chemical test for the unsaturation. So this is the chemical test for the unsaturation. As you can see here, if an alkene such as ethene is shaken with a solution of bromine in the water, then bromine loses its color, and then what will happen, the bromine has reacted with the ethene in this addition reaction, so producing a colorless compound. You can see here, this one, the B tube or the second tube here has a colorless solution, or the colorless compound is present in it. But if we talk about the first one, which has the bromine water has actually the reddish brown or red brown color is present there, so alkane does not react with the bromine water. Why? If we talk about C2, and then we have, this is the ethane, and the first member of the alkene is ethene. This one, ethene contains the carbon-carbon double bonds, but if we talk about the ethane, it contains carbon-carbon single bonds, and 3 hydrogen atoms are present with each carbon atoms like this. So this is the structure for the ethane and the ethene. So what will happen here, when we add the bromine in this one, and the second reaction with the alkene, bromine will react or act as a double bond that represent here, because this is a weaker bond. Alkenes are reactive, so they will break the bond that is present between the carbon-carbon double bonds, and the solution of the color will become decolorizes. So after the decolorization of the solution, that means you can say here that alkanes are already fully saturated and can't take part in the addition reactions, and alkane would give no reaction with the bromine water, so the solution will stay as red brown or orange brown. And the next, if we talk about the alkenes, as alkenes contain the double bond, so this is the test for the unsaturation, bromine water with the alkane and alkene hydrocarbons whose molecules contain at least one carbon-carbon double bond or triple bond will give the addition reactions, and after the giving the addition reaction, the solution becomes the colorless. That is the visible change when we see when there is a reaction between the bromine water and the hydrocarbons which contain the double bond or the triple bond. So a reaction in which a simple molecule add across a double bond of the alkene, that is known as the addition reaction. Through this reaction you can easily check is it a alkane or a alkene. So now the next topic is about the homologous series. So homologous series is a family of compounds. You can say that this is the family of the compounds which have a similar structure or similar name endings, like as we already told about the alkanes, alkenes and the alkynes. So they behave chemically in a similar way due to the presence of the same functional group. The family which contains the same functional group similar structure or same structure, and also third one, the similar name endings that are present in it. So that is the family. So in simpler words, a homologous series is a family of similar compounds with similar chemical properties due to the presence of the same functional group that is present in this. So all the members of such a series is represented by a specific formula, and the members of the homologous series have same characteristics, means they have the same functional formula, they have same general formula. You can say that, as we have discussed the general formula of the alkanes, alkenes and alkynes, and in the last they differ from a member to the next by CH2. They differ just by the CH2, the difference in the member of the families. They display a trend in their physical properties and they share the similar chemical properties. So we have four series or four families of the homologous series. The first one is alkane, alkene, alkynes, and in the last we also talk about the carboxylic acids and the alcohols. So they each have a different formula and they have similar chemical properties, they have similar physical properties. So we'll talk about here the functional group also. So you can see here in this table we have different homologous series, and first I will also tell you about the functional group. So you should know about this word which is known as the functional group, and then we will discuss the homologous series. So functional group, the atom or the group of atoms that are responsible for the reactions of a compound, that is known as the functional group, and that gives also the series its particular properties, that is known as functional group. So for this purpose, the carbon-carbon double bond, that is present in the alkenes is known as the functional group for alkenes. And if we talk about for alcohols, which has the functional group of OH, hydroxyl group, and alkanes, single bond, carbon single bond, or that is present here. And if we talk about carboxylic acids, the functional group for carboxylic acid is COOH, like this. So this is the functional group for carboxylic group, and all the members of a particular homologous series contain the same functional group, means all the members of the alkanes have carbon single bond that is present in them, alkenes have carbon double bond functional group, and alcohols have OH hydroxyl group that is present in their functional group, or you can say that in the members of the family. So in this table you can see here we have homologous series, alkanes, alkenes, alcohols, carboxylic acid, and the name of these will end with the if we talk about the alkanes, the members have methane, ethane, propane, butane, pentane with the prefix, and alkenes with ethene, propene, butene, pentene, hexene, heptane. And if we talk about the alcohols, then also you can use the prefix like meth and then methanol. Ol represents the alcohol, so the name ending with the ol: methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, so like this one, etc. And if we talk about the carboxylic acid, if in any compound it contains COOH as a functional group that is present in it, you call it as carboxylic acids or oic acids. You can also call it as the oic acid because the name ending with this one. So we have methanoic acid. we have ethanoic acid. Methanoic acid means just one carbon is present in it. Ethanoic acid means two carbon atoms are present there. So this is these are the homologous series of these compounds that are present there. And first, as we already told about we read about the alkenes and the alkenes, so now we'll talk about the alcohols. As alcohols, they have the functional group that ends with OH, means hydroxyl group is present in it. Alcohols are a homologous series of the compounds with the functional group that is hydroxyl group, and they have the general formula which is CnH2n plus 1. So this is the general formula for the alcohols, and the simplest member of this is methanol. As the name ending with the ol, then you can easily say this one is the alcohol, which has the formula CH3OH, like this. So this is the formula for the methanol, and this one is the general formula. Through this general formula you can easily check, OH will be present here also in this. So this is the complete general formula for the alcohols. CnH2n plus 1, and then OH is also added. I forgot about that. So methanol has one carbon atom per molecule, and its covalent bonding will be like this: one carbon atom, carbon, and then 3 hydrogen atoms are present there, like this. With these 3 hydrogen atoms we have OH functional group, which is the hydroxyl. So this is the displayed formula or the bonding of the methanol that is present here. The most important member of the alcohol series is the ethanol. Ethanol, which has the formula C2H5OH. So this is the most important alcohol. This is the second member of this series with 2 carbon atoms in each molecule, and 5 hydrogen atoms are present there. So note that the name of all the alcohols has the ending ol. You can see here this one, ol: methanol, ethanol, propanol, butanol. Early alcohols of the series are neutral, colorless liquids, and they do not conduct the electricity. So these are the properties of the early members of the alcohol series. So this is all about the alcohols. The most important things that you should know about, that you should remember: first the general formula, the functional group, the first or second or mainly 2 members of that family. That is the most important one. So next we will talk about the carboxylic acids. Carboxylic acids that ends with the oic acids. The carboxylic acids are the 4th homologous series that I display in the table. These properties of these acids are determined by the presence of a functional group which is COOH. So this is the functional group that is present in it, and the carboxylic acid have the general formula which is, this is also just like the alcohols, but difference is that in the end you just have to write COOH. In the alcohols we put in the end OH, hydroxyl group, but in this you have to put the COOH. So the first member of this series is methanoic acid, and the formula for the methanoic acid is, as it contains just one carbon atom, so the formula will be COOH and just one carbon. So this is also found in the stinging of the ants and the nettles. However, the most important of these acid is the second one, which is the ethanoic acid, and in ethanoic acid the general formula is CH3 and then COOH. So this is the ethanoic acid, which is the acid that is found in also in the vinegar. And now I will show you here the structure of the acids of methanoic and ethanoic acid. So first, if I show you here the structure of the ethanoic acid, that will be, we have carbon with one hydrogen atom that is present there. Carbon forms the two double bond with one oxygen and one bond with the other oxygen, and that oxygen has a bond with the hydrogen. The one thing that is most important, that carbon forms the four bonds and oxygen forms the two bond and hydrogen will form just the one bond. And next I will display you the formula for the ethanoic acid. So we have carbon carbon single bond, then OH, and here carbon forms CH3. So this is the displayed formula or the structural formula for the ethanoic acid and the methanoic acid. So this is all about the homologous series of alkanes, alkenes, alcohols, and in the last we talk about the carboxylic acid. The most important thing about the carboxylic acid is their functional group that is present in all the members of this family, which is COOH. So if there is any compound that contains this functional group, that means that is the member of carboxylic acid or this homologous series. The first member is methanoic acid, the second member is ethanoic acid, and the general formula that is present in this compounds are CnH2n plus 1 COOH. So this is the general formula. And now next we will talk about how you can name a organic compound. So now you can see here, this is the model of straight compounds like the alkanes, and we have methane, ethane, and pentane with their models. The alkanes are the homologous series of the saturated hydrocarbons, and as we already know that their name ends with the ane because of alkanes, and you can add the prefix in the first, so no matter how long the chain is. And the figure here you can see here that shows the model of the methane, ethane, and the pentane. So we have the prefixes to the name of the alkanes that are standard and indicate the number of the carbon atoms in those chains, like meth indicate the 1, eth indicate the 2, and prop 3, but 4, pent 5. So just like that we have the prefixes. So many different organic compounds are formed when a hydrogen in the original alkane is the backbone that is replaced by another group. So the product formed when ethene reacts with the bromine in the solution in hexane. So we have this figure like this one. If suppose we have hexane in a solution of hexane, we have like this one, we have a solution of hexane, and in this solution of hexane, what will happen, the product form when ethene reacts with the bromine. So when ethene C2, which is H4 C2H4, that ethene when reacts with the bromine, because this one is the double bond that is present in it, so just because of the unsaturation, and alkenes are more reactive, so that when they react they will form carbon carbon single bonds, plus we have hydrogen atoms that are present there like this, and as the double bond breaks, so bromine are attached to these carbon atoms. So for naming of a product of adding the bromine is 1,1-dibromoethane, means you can see here as there are two carbon atoms, so you have to name all the carbon atoms that are present in the compound like this one, and bromine is attached to first carbon and also bromine is attached to the second carbon. So you have to write the position of the carbon atom to which the functional group is present, 1, 2, and then you have to do or add any prefix if it is preferable, like di, as we have two bromines that are attached, so you have to write the prefix that is di. And for the bromine we can choose the bromo. For group 7 halogens, fluoro, chloro, bromo, that is the name that is added. So 1,2-dibromo, and the compound we have this ethane, as it contains two carbon atoms and a single bond is present in it, so you call it as the ethane. The chain, that is the parent chain, that is the ethane. So this is the process of naming the addition product of the ethene and the bromine. The product has two carbon atoms that are joined by the single bonds. So it is named after the ethane, and the molecule contains two bromine atoms, as you can see here, two bromine atoms. So you can use a word that is, or a prefix that is, dibromo. So now we have dibromoethane, and the last you have to add the position to which the bromine atoms are attached to the carbon atoms. If they are attached to the same carbon atom, then there is no need, but one bromine atom is bonded to each carbon atom, so the carbon atoms are numbered 1 and 2. So the full name will be of this compound is 1,2-dibromoethane. So the naming of the early members of the alkenes, alcohols and carboxylic acid is systematic and uses the prefixes and the name endings. So in the naming of the ethanoic acid, in which we have, like in ethanoic acid, we have a functional group which is COOH, that represents the oic acid. So the functional group is the counterpart of the carbon chain. This is true when naming any member of the carboxylic acid groups. So this is how you can name any member of the series of homologous series of alkanes, alkenes, carboxylic group, or any alcohols. And also the carbon atoms of the carboxylic functional group is counted as a part of the carbon chain. So like if we talk about the ethanoic acid, that means there should be two carbon atoms that are present in the chain. So the formula will be CH3COOH. So this carbon is also counted in the chain. In case of methanoic acid, there will be COOH and just one hydrogen. Because there is one carbon atom, so this carbon is considered or counted as a part of the carbon chain. So this is how you can easily name any you can say that any member of the homologous series. So now we have the structure formula. The structure formula of an organic molecule shows how all the group of the atoms are joined in the structure. Like for example, we have ethanol, and ethanol has the molecular formula which is CH3, CH2 and OH. This is the molecular formula, and the structural formula for this one will be, as we have one carbon and another carbon is present there, and with this carbon we have a functional group that is OH, hydroxyl group. This carbon contains two hydrogen atoms, as you can see here, and this carbon contains three hydrogen atoms like this one. So this is the structural formula of any organic compound. So in case of the structural formulas, for representing the formula of organic compound, this type of formula is not as complex as drawing all the bonds of a structure, but the way of representing the atoms of a molecule are arranged. And like ethanol, as you can see here, the molecule can be clearly represented by its structural formula with CH3, CH2 and OH. And we have some other atoms like we have butane, which is the member of the alkane family that contains 4 carbon and 10 hydrogen atoms. So in case of that alkanes, they are the straight chain hydrocarbons. So it is possible possible to have the molecules where the chain is branched. So in butane, all the 4 carbon atoms are arranged like this one, because this is considered as the straight chain. So all the carbon atoms should be in the straight main chain. However, atoms do not have to be arranged in this way. The 4th carbon atom can go off from the main chain to give the branch structure also, but the name will be changes when it gives the branch structures. So this is about the structural formula of the organic compounds. Next we have isomerism. Isomerism is the property of the compounds that have same molecular formula. The molecular formula will be the same, but there is a difference in the structural formula. So if the compounds have same molecular formula but different structural formula, you call it as isomers, and the phenomena is known as isomerism. So the property of compounds that have same molecular formula but different structural formula, the individual compounds are known as the isomers. Those are known as isomers, and the phenomena is known as isomerism. So the system of naming of compound also emphasize on the importance of the molecular structure. So the molecules with the same molecular formula but we have also different structures, like for example we have we can see here the structural isomerism in the butane. Butane, as it contains this is the fourth member of the alkane family, so it has 4 carbon atoms and it contains 10 hydrogen atoms. This is a straight chain hydrocarbon like this one. 4 carbon atoms are present in it with 10 hydrogen atoms that are placed here with the bonds that I have made. So this is the first structural formula for the butane. And if we talk about another one, or you can also make a different structural formula with this, which is by changing the position of the carbon atom in this, like you can place this carbon atom with this one. So then what will happen? We will see first carbon atom, second and third will be same, but what will happen, you place the fourth one with the second carbon atom like this one. If you place it here, what will happen? We have, first of all you have to complete the valency like this one. So the structure which is here, as it contains 4 carbon atoms C4 and 10 hydrogen atoms are there. 10 hydrogen atoms should be like this one. Here, so there are 10 hydrogen atoms that are present there, but now you can see here this is a different structural formula. So just because of the difference in the structural formula, the name also changes. They have same molecular formula but different structural formula. The name will be, for the naming of the organic compounds, as I already told you, that you have to take the straight chain first find out the straight long chain in any compound. After that you have to add the position in the carbon atom, like this is the first carbon, this is the second carbon, and this one is the third carbon. You have to choose the straight long chain of the carbon atoms in that compound. So after choosing this, add the numbers on the carbon atoms. So after that you have we have a methyl group that is present here. This CH3 is the methyl group. So now this is not included in this chain, as I already told you here this chain should be straight, right? So this is the methyl group, and this carbon atom is the second in this chain. So you can write the name as, we have methyl is attached to the second carbon atom, so 2. First you have to write the position of the carbon, next methyl, and then we have the 3 carbon atoms that are present in the alkane, that is known as the propane. So the name of this is 2-methyl propane because of the difference in the structure. So this one, as you can see here, we have a different structural formula which are known as the isomers but same molecular formula. So butane and 2-methyl propane have the same molecular formula but different structural formula. This is known as structural isomerism, and the structures are known as the isomers of each other. Structural isomerism can be shown by the members of any homologous series, and they can arise from arranging the position of the function group in any molecule. Like for example in alkenes, the 2 forms of butane which has the formula of C4 and H8. So this is the first one. The 2 isomers of these are the isomers of these but 1-ene and but 2-ene. That means In the first one, in the first isomer of the butene, what will happen? The functional group carbon-carbon double bond is present in the with the first carbon atom like this, and in the second one we have a functional group with the second carbon atom. So you can see here, these are the structural isomers of each other. They have same molecular formula, but again there is a difference in the structure. So the type of the structural isomerism where the position of the functional group is moved within the molecule also take place in the alcohols also. And in the examples of the alcohols, we have prop 1 ol. 1 represents the position of the functional group. That means in the propanol we have a functional group which is the hydroxyl group that is attached to the first carbon, and in the second isomer of this is propan 2 ol. That means the hydroxyl group is attached to the terminal carbon atom, and not in terminal. In terminal we have the first one, and in case of the second one, the hydroxyl group is attached to the central carbon atom in this. So a similar structure can also arise with the butanol or with other compounds like that. So these are the isomers in case of the alcohols, alkenes, and also we talk about the alkane isomers. Now next we will talk about the esters of carboxylic acids and also their isomerism. Esters are also considered as the organic compounds. This is a family of the organic compounds that are formed by esterification, and they are characterized by the strong and pleasant taste and also pleasant smell. So this is a homologous series of the organic compounds. So this series of molecules are the esters that are formed when there is a reaction between the alcohol and carboxylic acids. So when alcohol reacts with the carboxylic acid, we have a functional group, that is esters, that is formed. So for that reaction we have the example when alcohol and carboxylic acid are react together to form ester, that is ethyl ethanoate. The alcohol that we use here, that is ethanol, C2H5OH, that will react with the carboxylic acid, which is ethanoic acid, CH3COOH. So when they react together, what will happen? A water will be removed from this one. So when a water will be removed, we have ethyl ethanoate. How ethyl ethanoate is formed? By the removal of water. Hydroxyl group is removed from here. You can see that. From carboxylic acid, hydroxyl group is removed and hydrogen is removed from the alcohol. So this will form a water molecule. So after the formation or after the removal of the water molecule, what we have the remaining formula is CH3CO, and then alcohol will attach here, which is C2 and H5. So this is the ester that is formed by the esterification method, by the esterification between the alcohol and the carboxylic acid, and the name of this ester will be, we call it as you can see here, this one. So this is the ethyl that is attached with this, so you can call it as ethyl ethanoate. So the product that is formed here is ethyl ethanoate by the reaction between the ethanol and the carboxylic acid. Esters are named after the acid from which they are formed. The acid is indicated by the second most important part of the name, that means ethanoate. You can see here ethanoate here is the second part of this name, the alkyl group from the alcohol, that is ethyl from this alcohols in this case. So this is the first part of this name, the second part comes from the carboxylic acid, and the first part comes from the alcohols. So ethyl ethanoate is just one example of the series of esters. So different combinations of alcohols and carboxylic acid can produce different esters that are structural isomers of each other. So I will now show you here also the formula and the molecular formula, the structural formula of the different esters that are present in our series of esters. You can see here we have the name and the structure of some esters that are represented in this table. The carboxylic acid and the alcohols that are used for the formation of the esters that are present in the series, like the first one we have ethyl methanoate, then methyl ethanoate, we have ethyl propanoate, propyl butanoate. So all these, they have the molecular formula that is represented with their also the structural formula. So every organic compound can be represented by the several different type of formulas, and these formula are designed to give us the information about the composition and the nature of the compounds. The first and most crucial is the molecular formula that represents the actual number of atoms that are present in that molecule. Like for example, for the methane, the simplest one, the molecular formula is CH4. So for the ethane it is C2H6, sorry. So that represents the actual, or that shows the actual number of atoms that are present there. So the molecular formula does not indicate the structure of the molecule, it is the displayed formula for the compound that gives us that information. So a displayed formula shows the structure and also show the bonding in the molecule. So we have the examples of the displayed formula that can be seen here also in this table, and in the previous table which I show you, that they also have the structure formula or the displayed formula that show the bonding that are present between the molecule. So this is all about related to the organic chemistry, introduction to organic chemistry. We talk about the homologous series, the alkenes, and then we talk about the alcohols and carboxylic acids. We talk also about the different organic compounds that can be distinguished from each other by their molecular formula and the displayed formula, which is the structure formula. And in the last, we talk about the homologous series and also the isomerism and isomers, and structure and displayed formula of the members of different homologous series containing up to 4 carbon atoms included the unbranched esters that are formed from such alcohols and carboxylic acid that can be drawn to represent the bonding in the different molecules. So this is all about today related to chapter number 18, which is the introduction to the organic chemistry. In the next video we will talk about the next chapter, which is reactions of the organic compounds, that we will discuss in the next video. So hope you understand all this. If you have any question, any query, you can ask in the comment box. If you like the content, then please subscribe our channel and share it to the others. We will meet in the next one.